This example can be found on slide 12, example 2c. Now this is quite tough. I need to differentiate cotangent inverse, but I'm only given sine inverse, cosine inverse, and tangent inverse. Hence, I will need to use one of these rules that was in the first example that I've gone through, where cotangent inverse is actually tangent inverse the reciprocal. So use this relationship to change this question first. So I can rewrite this equation to become tangent inverse followed by 1 over 2x plus 5 square. So now I can use this formula to differentiate this, where my u looks quite complex. So let's start. To differentiate tangent inverse is this formula. So I have 1 over 1 plus u square. Then differentiate u. Okay, so there's a lot of simplification here to be done. Let me first square the square. I'll have 1 over 2x plus 5 power 4. Now, by chain rule, I have to differentiate 1 over 2x plus 5 power 2. So this is actually 2x plus 5 power negative 2. So let me do that. Power bring down, which is negative 2. Power reduced by 1. So minus 2 minus 1 is minus 3. Then differentiate the inside, which is 2. Now let's continue to simplify this. I will have, on this side, I'm just going to let it remain as it is. Now on this side, I can simplify to, okay, now what I'm going to do is I'm going to take the numerator multiply to the numerator, the denominator multiply to the denominator. So 1 times negative 4, 2x plus 5 power 3 times 1, 2x plus 5 power 3 times 1 over 2x plus 5 power 4. You can see a cancellation here. So now I'm going to neaten this up a bit by multiplying top and bottom by 2x plus 5. So finally my answer is this is it. The last example is on slide 13. I'm supposed to find the slope, and we know by now slope means to find gradient, which means to differentiate. So I have an expression here which means there's a product rule, and I have a cosecant inverse which I have to differentiate, and I need to use this relationship. And then after that I have changed this to sine inverse. So let me first do that. Let me rewrite this relationship to be, or this expression to be, cosecant inverse will be sine inverse 1 over root x. So now I will have to differentiate sine inverse, and I'll use this. So let's start. So by product rule, I will keep x squared, differentiate sine inverse. When I differentiate sine inverse, this is my u. So I have 1 over square root 1 minus u squared. If I square this, the square root will disappear. And then by chain rule, I have to differentiate u. Okay, this is only one component. The other component is to keep sine inverse and differentiate x squared instead. Okay, now it's all just simplification. I'm going to focus on differentiating 1 over square root x. So 1 over square root x is x to the power of negative half. Let the power come down and power reduce by 1. Copy. I'm now going to rewrite this part in a nicer way. Now this means x to the power of 3 over 2. But x to the power of 3 over 2 also means x to the power of 1.5, which means there's an x and another power half. Okay, so now I can see that I can cancel a copy of x with an x. And now I'm going to combine this square root with this square root. So I can multiply the square root together. So I'll have a negative x. So square root and square root multiply together, x times 1. And 1 over x times x will cancel. And on this side. So that is the answer for dy dx. But that's not the end. You will still have to sub x equals to 2 and calculate the values. Now for this, please make sure you are calculating in radian. Can you try it and find the answer? That means, let me do it here. When x equal to 2, you will have to substitute 2 here, and 2 will cancel. So I have negative 1 over square root 1. That's another 1. Plus, there's a 2 here, there's a 4. Sine inverse. There's a 2 here means there's a 1 over root 2. Interestingly, sine inverse 1 over root 2, if you know your special angle, the answer is pi by 4. This part is pi by 4. So multiply by 4 is a nice pi. So my final answer is simply pi minus 1.